The idea behind Radix sort is that you're using the inherent mathematical properties of base, like numbers, and like the fact that they're like base 10. You can use any base actually, which is interesting. But effectively, if you look at a number like 110 and 5 and like 70, if you wanted to organize this with Radix sort, what you would do is you'd look at the last digit first, and you would sort on that. We go through this list, and you can imagine this being, like arbitrarily long. The first digit is what determines the place in that index. So the numbers are from 0 to 9, so literally 0 to 9 indexed. And I would put this number first. So actually the order that the array comes in is the order you just put it in. So this would go in the 0th index. This is 110. And then the 5 has a remainder of 5. So this is 0, 1, 2, 3, 4, 5. So the 5 would go here. 70 ends in 0, so it actually goes right after this. And you basically just repeat this process the number of times that it takes to get all the length of the digits, basically. So this is 3 long, so this is like max length is equal to 3. So that's how many iterations we'll need. So equals number of iterations. Okay, so we need to do this 3 times. And again, you can imagine this being like, more numbers put into this, but we'll do these 3. The second iteration, you go by the second digit. So in this case, it's the 1 here. There's effectively a 0 in front of the 5, and then there's a 7 here. So that's what we go on. So I will take this list. So I'm going by list 5, not this one, not the one on line 4. I go on line 5, and I will sort that in the order that I see them. And that's an important part of it too. As long as everything is like in its proper static place, that's how the ordering will work. So I'll go here and I look at the 1, and sure enough, the 110 belongs in the index 1. 70 belongs in 7, so that's 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4, 5, 6, 7. So that goes here. So that 70 is there. And 5, remember, it has a 0, so actually it goes here. And then we do it one more time because this is the third time. Third time, we do the exact same thing, except we go by the third digit. In this case, there's a 0 in front of the 5 and a 0 in front of the 7. So the 5 goes first. The 110 goes in the 1's position. And 70 is in the 0th position, so it goes after this. And because we did it 3 times, we're actually done. Now we just need to flatten the thing, but effectively we have this order. And that's how Radix is effectively working. Let's do a function. Call it Radix sort, give it an array. And let me just make an example array here. Let's do a bunch of numbers here. I want to kind of limit this a little bit though. So max equals, so this is the range from 0 to 999. Okay, cool. And then I should call Radix sort on the array. I want to just console log that. Okay, cool. So let me just run the code real quick. I think I'm in my JS. Radix sort. I should get undefined perfect. So this is working as expected. Okay, so what do we do first? Well, so first we need to find max length. That equals the iterations. So that's the first thing we need to find. So I need to loop through that. That's a big open. I don't think I want to loop through it while I'm doing this step because I think it's kind of messy. So I'll just do this quick. Then I need to create empty. Basically, it's like a sort of counting sort kind of array. And then I just keep doing that. And I place and pull from previous. So that's another important point. The previous array needs to work as well. So I think I need to like do first. Place into first. And then I can like do my iterations until done. Then I need to flatten and return that. I think that's what I'm going to do. Let max number equal negative infinity. I need to find max price, so I'm going to say 4. const num of array, and we're just going to I guess like be really succinct. So max equals max of num, or the max and then the num. So that'll give me my max. Then I want to create an empty sorting array. So here's the thing. I'm going to be repeating this process of creating this empty array. So I actually want to just abstract that to another function. I think that makes sense. So I'll call it my create sorting array. And I think I can do return array. So here's a funky thing you can do. Array from. You can give it the property length, and we'll use 10. And you can provide a mapping function, which is used across the entire array. And actually, what I'm just going to do is provide a arrow function, just create an empty array. So this will create an array of length 10, and then it's going to map and fill that array with empty arrays. That 10 is because we're dealing with base 10, and we don't need to do that necessarily. So I'm going to create even though this is like a little extra, I just want to be explicit, like this could be any base really. So this should work. I want to just check this out very quickly. I want to say my let store sorting array equals create sorting array. And I just wanted to return that real quick just to see what that looks like. So let me just do that here. Okay, there we go. I got my empty array. All right. Now we need to do our first placement. So here is actually something I maybe need to go over a little bit more, because while I'm looping through this, so this, I'm looping through this, I need to get, an important point to note here. The array needs to have all positive numbers and their integers. So there are some restrictions on what you can use this for. We have here, so for each number in the array, I need to like get first digit. How the heck do I do that? If I do modulus 10, let me just check that real quick. So if I have like this weird number and I do modulus 10, I get the remaining number, right? So that's useful. Yeah, so that's what I'm going to do. I'm going to do first 10 is const first digit equals num modulus 10. And that would be my index of the sorting array. So that's what I'm going to do here. So I'm going to do first digit. That equals, and I want to push the number into that empty array. Okay, so let's see what this looks like when we are I'm going to return sorting array. Just see what that looks like after we do it. Okay, let me get out of here. Clear that. Okay, here we go. So we have our 0. So 0, 1, 2 ends with 2, 3, 4. Okay, so this looks good. All right. I need to do my iteration. So this is actually one iteration down already. Say max minus really, because that's done. Wait, hold on. Max is not what I'm. Oh, hold on. Max is not what I'm trying to do. Max is not it. So this is let iterations equals string of max, and then you do the dot length of that, and I want a -1 because I just did one iteration effectively to get it into this initial sorting array. I'm going to call this actually previous sorting array, because I'm going to be creating a new one with each iteration. I just want to like reset that to the previous one, or reset the previous one to that new one. This number here, if I do, okay, now I need to think about like the next digit, right? So let me do node here. If I take like this number and I do modulus 100, that doesn't give me what I'm looking for. I want the remainder, right? So what I want to do here is actually, you know what I want to do? I want to do this number divided by 100, and then I want to divide it by 10 then. And then can I modulus 10 that? Does that work? Okay, so I need to do math, math.floor. that gives me the 5. Okay, so that's how I'm going to try and get around it. And if I want it the next place, I would do divided by 100. And that gives me the 4 that I'm looking for. Okay. So actually, I kind of want to like institute it here. So that's what I'm going to do here. I'm going to do this up here where I'm like, so my iterations, I want to do that earlier and then not subtract 1 because that seems a little hacky. I'm going to do a for loop for, or I should say while iterations is greater than 0. And I'll do my iterations minus here. Okay. That's a little early here, so let's do this. I think I will make my array like this. So it's an array within an array of length 1. And that's my previous sorted array, which is not really sorted. And then I will need to create a let current sorting array equal that, and create a new one. Okay, and I'll set that later. So at the end, I want to decrement the iterations and set the temporary sorting array that I made that will be actually taking in the values and set to the previous, so that the previous is something I'm pulling from. So I'm not pulling from number of array, I'm pulling from kind of like a separate loop here, because it's going to be nested. So this is a nested operation, because every time I go through one of the sorting arrays here, it's going to be an array of arrays, so it needs to be this way. Okay, so for sub array of the previous, then I do num of the subarray. Okay, number of subarray, and it basically it's the same thing here, except my iterations are what matters here. So this is where I'm pulling this from. So actually, let me do a function called get digit. Choose a function which gives you a number, and this is going to be the number in here, and this is going to be the power of 10 to the return math.floor the number. Maybe I'll do like I instead, and then I say let I equals 0. I say while I is less than I'll say 1 here actually, is less than or equal to iterations. Then we'll do that, and instead of this, I'm doing I plus plus. So you're going up to it, and that means power of I. So that should be 10 to the first. Okay, I think that would work then. And I floor it, and then I get the 10th digit, basically. Okay, so get digit is a function that is being created every loop to return that current loop's digit place. And I think this will work even for small numbers. So if the number is less than like that, if the number is like 4, this should give me 0 because there's a 0th in that position. So this works as I think it does, and this is now get digit of the number, and this is now just the digit, and this is now just a digit. Okay, cool. So for each subarray within the previous sorting array, I'm going to put the number appropriately in the right place of the current sorting array. Current sorting array gets the digit, push the number into it, and you do that many times, and you're pulling from the previous. Okay, cool. So I think this actually works the way I think it does. Iterate until done. Iterate until done. I don't need to place into the first because I'm including that first within my iterations, which I think that makes sense, by the way. This is me setting up array for nested looping. All right, cool. And then I think I need to flatten. So let me just see what this result looks like for now. This is I'm going to return previous sorting. Let's see what that looks like after that many iterations. And clear. Okay, I have everything. Ooh, what? Okay, so I think I did something wrong here. I think I went one more than I needed to, because everything's in the zero. That means I don't need to put equal to. I need to do one. Okay, that looks a little better now. Curious how this worked out. Like this should be, so this in this first position should effectively be sorted, and it kinda is. I think it might be my eye. I think I need to start with 0. I think if this starts with 0, my power is gonna be 1, and it's just gonna be my number divided by 2. Okay, that makes sense. Okay, there we freaking go. Yeah, I need to divide by effectively 1. The first iteration is just the number modulus 10, basically. So that does make sense. Cool. So this looks like it's working properly. Now I just need to flatten the array, and I think there's a way of doing that in JavaScript. Oh man, I forgot how to do. I think you can just spread. You can just spread. Yeah, right. Spread or flatten. Hold on, I'm gonna Google this. Gonna Google this. I think there's a way of doing it. JavaScript flatten nested array. I think this is easier said than done. Flat depth 1. Array 1 dot flat. Seriously. Okay, I'm doing it. Dot flat. I did not know that existed, by the way. This is the first time I'm hearing about this. Oh, yep. Flat is not a function. Of course not. Okay. Yeah, reduce concat is a thing too. I think I like this a little bit better. Okay. Okay, let's do that. So concat value, and the accumulator is the empty array effectively. So this empty array here is what we are effectively returning. Yeah, okay, I like that. That does make more sense actually. The flat, I'm surprised that the dot flat doesn't work, because that's like really nice to have. Oh, it's maybe not everyone has it. Internet Explorer doesn't have it. Oh no, but it says Node.js does it. Oh, Node.js has it, but I don't think I've updated my node. I need to update my node. Okay. Anyway, I'm like talking about something else. This works now, so yay. So here is my Radix sort. I'm sure there are maybe better ways of doing it. Let's think about time complexity here too. So this is definitely big O of n. That's one place. The thing to note here is that this counting sort is you can call it like length k. And these iterations are like length of like the max digit, right? I want to call that D. Okay. Okay, so here are some variables that we're going through. So this thing is happening D times, this loop here. And for each one, I'm sorting into, I guess I'm still like going through n number of numbers, except it's like a length k array, but they're like nested inside of it. So, I mean, in the end, you're still grabbing n elements, right? So this is like big O of n, big O of n times k times d. Is that right? Oh, I need to put the space here. Yeah, that makes sense. So it's big O of n times d. D being the length of the longest digit. And this sorting, this reduce here is like basically big O of n anyway. So these are less important, and therefore this is the most significant part. That's Radix sort. It's a way of sorting in n times the longest digit, which, if you think about like other sorting algorithms, which are like n log n, then this is possibly, as long as you fit this particular criteria, they're all positive numbers, they're all integers, and so you meet these restrictions, you can do sorting in pretty good time. Anyway, I am done with this, and I hope that was helpful, and I will see you next time. Bye.